All right, so let's take a look at the next question. So it says here, how many molecules of carbon dioxide are produced when 300 molecules of ethanol are allowed to react? Okay, so X is we're looking for the molecules of carbon dioxide. So remember, the setup is exactly the same we looked at before. So the unknown is in the numerator on the left, which is how many molecules of CO2. The number in the denominator is what we have. So we have 300 molecules of ethanol. I'm just going to put this here. So on the right-hand side, we're going to put the coefficients from the balanced chemical equation, and we have to match it. So CO2 is in the numerator. So I'm going to put 2 CO2 in the numerator on the other side. Ethanol is in the denominator. So 1 ethanol is on the denominator on the other side. So now we're going to solve for X. X is going to be 300 times 2 divided by 1. So 300 times 2 is 600. 600 divided by 1 is still the same. So that means there are going to be 600 molecules of CO2. Okay, now whenever you're doing the setup for this ratio, this is essentially the minimum I need to see. I need to see the setup of your equations, and then you can go straight to telling me what X is. Okay, but I need to see what you have set up where, and then you can just give me the final answer. So here we have our next one. So how many molecules of O2 are needed? So we're looking at oxygen now to produce 550 molecules of CO2. So we have 550 molecules of CO2, right? So notice you can be given information about anything here. As long as if it's something in the balanced chemical equation, you can create, remember when we looked, you can have a whole bunch of different ratios. I can do ethanol to oxygen, oxygen to water, water to carbon dioxide. Like, it does not matter what you have here, as long as if it's in the same balanced equation. So we want oxygen and carbon dioxide. So oxygen is 3, carbon dioxide is 2. So over here, this is going to be 3 oxygen over 2 CO2. So when we solve for X, it's going to be 550 times 3, right? 550 times 3 divided by 2. So this ends up being 825 molecules of oxygen. Okay. So what this is called, this setup, is essentially called a ratio from the equation. Okay. It's also referred to as a mole ratio, which is what we're going to look at the next one, but it's exactly the same. Okay. So part C. How many, so we have, here's the reaction. So it's just how sodium sulfate, phosphate can be prepared by combining sodium hydroxide and hydrogen phosphate. So here we have the balanced chemical equation. How many moles of NaOH are needed to produce 5 moles of sodium phosphate? So it's important before we continue on for you to understand. These ratios that we're looking at can be only used for 2 things. The number of something. So it's like, when do we use these ratios? So they're technically called mole ratios. So they can only be used for the number of something. So like number of atoms, number of molecules, number of whatever. So notice everything we did in this part was molecules. So we were solving how many molecules, how many molecules. You can also, of course, the main reason why it's called mole ratios is because you can use it with values of moles. These are the only 2 things you can use these ratios for. So you cannot put mass, you cannot put concentration or volume or anything else. It's the number of something, so number of atoms or molecules or ions, and moles. Okay, so part C here, we're now looking at moles, but the setup is exactly the same. So up on top, we're trying to solve for moles of NaOH. On the bottom, we have 5 moles, and make sure we're going to start putting in units of moles, and this is for sodium phosphate. Okay, now it's very important that you label these because it's going to help remind you also what numbers you're using on this side. So moles of NaOH, this is going to be 3 NaOH over sodium phosphate is a 1. So when we cross multiply, it's going to be the same thing. 5 times 3 divided by 1. So this is going to be 15 moles of NaOH. Okay. Now, don't worry about sig figs for mole ratios. Okay, and the reason why is because this mole ratios that I'm introducing you to today is going to be a concept we're going to use in the next lesson for a bigger question. So this is going to be really just one small part of a larger question you're solving. So even though this is the final answer right now for us, when you actually go to do the real stoichiometry problems, this is not going to be your final answer. So really the goal of today, the goal of this introduction lesson is for you to get comfortable doing this setup. It's very important that you get comfortable with doing this part because it's going to be important for you to get the correct answer, of course, when we start adding on. Okay, we're going to build on to this tomorrow. So over here we have how many moles of water, so we want to know moles of water, are produced if 12.8 moles of phosphoric acid are allowed to react with NaOH. So we have 12.8 moles of NaOH. Okay, so we're going to look at our ratio. So we have 3 water and 1 phosphoric acid. So we're going to have 3 water. Oh, pardon me. I labeled this incorrectly. It's like I thought the question said phosphoric acid. Okay, let's just relabel this properly. Okay, so this is a 1, right? We looked at the equation up there. So to solve for x, it's going to be 12.8 times 3 divided by 1. So that's going to be 38.4 moles of water. Okay, so these are mole ratios. So remember, mole ratios can also be used when you're doing numbers of things, numbers of atoms, numbers of molecules. So give this one a try, this last part here. So we have ethane gas, which is C2H6. It undergoes a combustion reaction. The following equation is balanced. Okay, so be careful. Sometimes the equation is not balanced. Always double check that first. So how many moles of carbon dioxide are produced with the presence of ethane gas and 2.73 moles of oxygen? Okay, pause the video and give this one a try. All right, so X is moles of carbon dioxide. Here we have 2.73 moles of oxygen, right? So from the equation, we have 4 carbon dioxide for every 7 oxygen. So this is going to end up being 2.73 times 4 divided by 7. So we get 1.56 moles of carbon dioxide. All right, so practice setting up your mole ratios. Do the homework for this section because we're going to build on this in the next one. And if you don't have a good grasp of this, you're going to have a difficult time, okay? Okay, until next time.